Well, morning guys. We're above freezing, so that's a nice change. I decided to finish the day up yesterday by taking all of the baluster stock, all of the 2x2s, back to the shop, and I just used the miter saw there. And sometimes like that, it's sometimes on these things it's a lot faster to be able to just set up a stop and just whip through the stuff. So we got 3 different lengths here of spindles or balusters, and anyways, there's 2 different layout methods we'll be using today on the install. One for the horizontal sections of the landing and another part for the slopes where the stairs are, and we'll just cover that as we go. Once you start getting around the 0 mark, your gun can start to freeze up. Something to do with the way the air moves through the gun. It'll actually make it a little bit colder than it actually is. So, a day like today, we're 1 or 2 degrees above freezing. That's still cold enough that the gun can ice up. Usually not so bad on something like this, but if you're doing something, if you're nailing down decking or something like that, heavy nailing sequence, or you're putting in shear wall, that's a great example of when the gun will start to freeze up, and you'll start to be, you might find yourself troubleshooting something that's internal and you can't really notice. Generally, the first signs of it freezing up is it starts to get a little sluggish. The piston operation gets a little sluggish, and it'll almost seem like it's hanging a little bit on something. It's also I should note that this is Bostich's winter grade, but it's actually a tool lube. So it is primarily an oil, and it just has a little bit of something in it to keep the gun from freezing up. I'm just verifying plumb on the first one before we start nailing it, and that's just sort of a double check that I didn't make some sort of mistake with the story stick, like flipping it around backwards for end or whatnot. Not that I've ever made that mistake before. Okay, one, line up the other side on an angle. You'll notice that when I'm nailing these in, I'm using opposing angles, and that's something deliberately that increases the strength and long-term durability of this project. By putting one nail in on an angle this direction, the other angle up on this direction, those 2 nails, one cannot pull out without the other one to drive in. And because we're already tight in our joints, there's no room for that to go. So these will not work loose. These will last the long run. Okay, now we're up on the other side here. We're going to drive 1 more nail per connection point from this side in. And these guys don't have to be at an angle. These are just going to go straight through, and they're just going to add increased bearing capacity for one of these. Watch out, please. Thank you. Okay, so like I mentioned, we have 3 different lengths of balusters here. That's because we have 3 different dimensions that we're dealing with in terms of slopes and flats. These guys here were cut to 47 inches. And then with stairs, you have to remember, as the steeper the staircase, the longer your baluster has to be. So in this case, we got 42s that'll go here. And we got 43s that'll go over here. Now on the flats, you may recall I used a story stick like this. It's really quick to do one of these up. But on the slopes of the stairs, you can do a story stick. But I want to show you what happens. I did an example here. It's fairly intuitive, but it's also an area you can make a mistake. It's important to me that I have the spacing in between these balusters even. regardless of whether this is on the landing or on one of the stairs. And I also want the spacing on the two different sets of stairs, with which each have their own slope, one at 32 and one at 39 degrees. I want the spacing to remain even as well. So one thing that we have to keep in mind is that as we go on a slope, our distance in here will appear to change, because what we're essentially doing is we're taking a cut like that. And this distance is greater than this distance. But this distance is the same on here as this distance. Hopefully that makes sense. If it doesn't make sense, I can come back to this. So one thing we want to keep in mind also is if we use a storyboard, that once we've figured out what our appropriate layout is, we want to be careful of rounded corners. Now see how this has a pretty crisp corner? It's fairly easy to determine where that line goes. So when you transfer the marks from here onto your guard boards or railing, you can be fairly sure that you're getting it fairly even. But now let's look over here. Let's look at this guy here. See how much curve there is? Let's just put on an imaginary line. Just like that. Now where exactly is this point here? Well, if we're setting directly over top of it, we can see it's right about there, that it's in line. But in reality, when you are viewing this from this side and you're working with ticks like that, another board, the reality is that it's very easy to allow the parallax of your eye, unless you are directly in line with it, to give you a false reading. Same type of idea as if you look at your speedometer from the top of the speedometer on your car or from the bottom of your speedometer in your car. Depending where you look at it from over here, it may look like it's reading 60 miles an hour. From over here, it may look like it's reading 50 miles an hour. The parallax effect also comes into play for us carpenters. So generally, I am not a very big fan of using story sticks on angles, because to make them accurate, it takes a lot on the setup stage to make the story stick. To make this took me a minute to make this stick, no problem, and then I transfer my marks over. But if I were to make this as a full, say, 5 or 6 foot story stick or longer, I would probably be in it for 5-10 minutes, I don't know. And then I'd be worried all the time that I might actually be marking like that instead of, or maybe like that, depending on where you view this line. So I find it easier to use a spacer block and to use a level and do a check every 3rd or 4th baluster or so, and just make sure that we're staying plumb like we should. Is it absolutely the most accurate way? Well, probably not. If you really wanted to do this well, what you would do is you get yourself a piece of 1/8 ply, and you would do your layout like this. And then, because that ply would be so thin, there would be no mistaking where that line comes, and you could make your marking off of that. Have I ever done that? No. Will I? Probably not. So anyways, this is just a little bit of background information on a couple things that you want to keep in mind when you are doing your spacing for your balusters on stairs that may have different slopes versus the flats, etc., etc. Oh, you can't have it yet, I'm sorry. I know, you want to play. Just 1 minute. Just wait. Oh, he's waiting for me to throw it. For us here, our code requirement is that in no place in the guard system, or aka railing, will you be able to pass a sphere through that is 100 millimeters in diameter. 100 millimeters is something like 3.95-ish inches. So for all purposes, roughly 4 inches, which is roughly what this ball is. So you can see that if we did not carry down the baluster, we would have a problem because we would be able to pass through. Now, do you have to go and check everything with a sphere or with a ball? No. You'll get used to knowing in what applications will you run into troubles and in what ways you can mitigate them, and it'll never become an issue. But you do have to keep this in mind. Okay, thank you very much. Another thing that we want to keep in mind is what's called a no-climb rule. And in most places have some sort of variation of this and certain stipulations as to when it applies and when it does not apply. But in short, it basically says that a child or somebody will not easily be able to climb over the guard, or that your guard construction shall not be of a design that facilitates easy climbing. So an example would be if we had rails that were like this, and another one, etc. We essentially are creating a ladder. That's something that would not pass code. So a couple little things just to keep in mind as you design and construct your railing. And remember, it's always easier to make amendments now at this point. You don't want to be making an amendment afterwards because your inspector failed you due to some sort of unseen design flaw. So let's talk design basics for a second. Taking a few minutes, or a few seconds for that matter, at this stage can really increase the overall appeal of your finished project, even on a very basic budget-conscious project such as this one. Something we want to keep in mind right now is, do we want to start at this end or do we want to start at that end? Well, are there any rules regarding this? Yes and no. No in terms of anything code related, anything you would see that's a safety concern that would be reflected by code. Yes in terms of aesthetics. What I want to recognize is that this corner in generally is going to be the most viewed corner or spot of the staircase. The eye naturally wants to go up to here. And down at the two bottom corners, they're not going to be seen as much, they're not going to be scrutinized by the eye. So if we were to start down at that corner and we start with a perfect 3.5 inch or 3 3/4, whatever you're using for spacing, and we work our way up, well, there's a chance that we might end up with our final baluster right there. And then on this side, we might end up with our final baluster right here. And our spacing is going to look very unbalanced if that's the case. So whenever possible on something like this, we want to try to maintain symmetry. So we're going to start on this end with our spacing and work down. And we're going to start up top here and use our same spacing and work down. And that will ensure that what the eye sees is generally acceptable. So in this case, I went with a 3.5 inch spacing. It's really easy. It's a common spacing. And it happens to match up the dimension of a 2x4. A situation where you may have to go with a more custom, a situation where you may find yourself going with a specifically determined spacing, maybe for example in the use of glass panels. If you have 9-foot spans and you're installing 8-foot pieces of glass, you want to make sure that you divide your spacing on each side of that glass evenly, such that you have that symmetry we talked about earlier. But in a case like this, you can just go with something straightforward, like the width of a 2x4. So requirements for our 2x4, or our spacer. For starters, I want something close to the full length of our baluster. I don't want to be using an individual block here and an individual block up there, because as the block is shorter, even though you may think you'll keep this perfect, trust me, there will be a time where you get a little bit of cockeyed. So having the full length for the edge of the baluster to register against is going to help with that. And although this seems very slow, deliberate, methodical right now, when you're working by yourself and you are really getting into the groove of something, you're just flying. You go pretty darn quick. Finally, to double check our work, every 3rd or 4th baluster, I'm going to check it for plumb and just make sure that we're on spec. If we need to make a little adjustment by checking every 3rd or 4th one, our adjustment may be, say, 1/8 of an inch. What I don't want to do is I don't want to put a dozen balusters in before checking plumb and then find out that I am 1/4 or 1/2 of an inch out due to cumulative error, and at which point it's too far gone to correct and you have to rip it out and do it again. So by checking every 3rd or 4th one, yeah, it takes an extra 10 seconds. But we can make small adjustments as needed if we find that we're starting to incorporate some sort of cumulative error. So we place our spacer up. Make sure that we are orientating our bottoms so that they're all the same. Once again, it sounds easy. It sounds like a mistake you wouldn't make, but when you really get moving, these things happen. Grab our gun, nail in our opposing angles, and we're going to come in later. We're going to put an extra nail in from each side from the back side, and that will really lock these in place. Although the level didn't really fall that great of a distance, dropping a level or a square onto concrete really can take one out of spec. Carelessness on my part. Now we got to check that level. This is why carpenters always have at least 2 trustworthy levels and 2 trustworthy squares. So you can check one against the other. Anytime you have a real hard hit, you want to check them. That's okay. Yeah. Looks like we're good. Got scot-free on that one. You know, something's been bugging me on this project, and it's this thing right here. This is part of the existing that was going to stay, and you know, it's all split up. It just doesn't look good. Is it a safety concern? Probably not, but it's just not right. So I decided I'm just going to cut this out. I'll give them a 2x6 so we can clean this up properly, and we'll make this look a little better. Yeah, good stuff. We can just pull these out. Because where this post here is placed, I have to get a little bit creative. We also want enough room back here. We can place some balusters. Okay, now that I got bearing on here and on here, I'm happy. So in this case, it's kind of determined for us. There's only one way we can start working off of it, and that is off each side of this post, because it would be a shame if we spaced it out here and our last one ended up right around here. Our post is 3.5 inches wide, so it only gives us 1/2 inch to play with before we have to worry about possibly not stopping that 4-inch diameter sphere. Well, between getting the wood and doing that little extra freebie there, that cost a couple hours, but it sure does look better this way. So like we talked about a little earlier, starting off this edge, working down, so we stay symmetrical to that corner. Right on the money. All right, this is a perfect example of what I was talking about matching the spaces so that we get symmetry. And you see how this one here ended up like that, and that's fine. It doesn't look like a problem at all. But if we ended up starting at the bottom, working our way up, and we had it at the top, we would then lose the symmetry of this corner. That's a little bit hard to show on camera, but yeah. So there you go. Case in point. Well, thanks very much, guys, for joining Finn and I on this build, and we'll see you next week where we finish up with the handrails.